Good afternoon, everybody, and welcome to the final part of our webinar series, Industry 4 and the Digital Transformation. This week we continue the journey through the pillars of the fourth industrial revolution and hopefully show examples of how Irish companies and SMEs have demonstrate the effectiveness through case studies. Our special guest this week will be Brian Cooney of KUKA Ireland, and yeah, this is the last in the four-part series. We will be rerunning the series starting on Tuesdays, which will be a similar theme, but some new examples and some new content also. So I'm going to hand you over to Billy, who will introduce the rest of the webinar. Thank you very much.
Thank you, Paul. Let me just share my screen. Dara, I've got a host disabled sharing screen error. So if you can just
try again there, Billy. Should be sorted now.
Right, that's sorted. Good, thank you. So what is Industry 4.0 and the digital transformation? My name is Billy Schofield, and I've got 37 years experience of working in advanced manufacturing. And what I've been doing over these last few weeks is sharing with you some of the things I've learned about Industry 4.0 and the digital transformation. So thank you for attending this webinar today, and thank you to Paul and the SkillNet team for inviting me to talk with you today. So this is the final of our series of webinars on Industry 4.0 and the digital transformation. And you should have a better understanding of the Industry 4.0 concept and how to apply it in your setting at the end of this series. So this is webinar 4 of a series of 4, the final webinar. The webinar series has been the introduction to Industry 4.0 and the digital transformation. We completed webinar 1, where our guest speaker was Dr. Ali. Webinar 2, we done a deep dive into augmented and virtual reality with James Corbett from SumVirtua. And webinar 3 last week, our guest speaker was Dr. Ian Keeney from Skellig AI, where we done a detailed look at artificial intelligence. So this week, webinar 4, we'll be looking at future trends, a roadmap of advancement, how to go about building your own roadmap for Industry 4.0, and super excited to have a robotics guest speaker this week, Brian Cooney from KUKA Robotics, who'll share with us some of the advances that's happening in automation and robotics in the world and here in Ireland. All these webinars are recorded and are available on the Industry 4.0 SkillNet YouTube channel. If you signed up for the series of webinars, you should have access to all of the recorded webinars, so you can review them at your own leisure. So the agenda for today, we'll be looking at introduction. We'll be talking about future technology trends. What's the future going to look like? What will be the main technology trends of the 20s? What will things look like by 2030? We'll talk about a roadmap of advancement. We'll talk about how to build your own Industry 4.0 roadmap. And then we'll have our guest speaker today, Brian Cooney from KUKA Robotics. We will be doing a Mentimeter survey today. It is completely voluntary. If you don't want to participate, you don't need to, and it's completely anonymous. But if you do want to participate, just open a tab on your computer or on your smartphone at www.menti.com, www.menti.com. And later on, when it comes time to take part in the survey, I'll share with you a code that will allow you to participate in the survey. And it's just for a bit of fun and to gather a little bit of data on people's interests. So over the last 3 weeks, we've been exploring the Industry 4.0 factory and its core concepts. So we've spoke about the connected and smart factory, a factory where all the where equipment in it is fitted with sensors, and those sensors upload data from the shop floor directly into our IT systems via the internet. We've spoke about cyber physical systems, where we have control systems and software and algorithms controlling physical processes within our factory. We spoke about cobots, robots that assist their human operators, and we'll hear more about that today with our guest speaker. And then we spoke about the roof of the Industry 4.0 factory being about employee empowerment and how that's often overlooked in an Industry 4.0 setting. But it's really important, how do we empower our employees to make better and quicker decisions in an Industry 4.0 setting. Then we looked at some of the tools that are available to us in the Industry 4.0 factory. We've spoke about digital twins, augmented reality, cybersecurity, 3D printing, data analytics, and last week we spoke about artificial intelligence. We've done a number of polls through the last 3 weeks, gathering data on people's interests in Industry 4.0. On webinar 1, we polled what Industry 4.0 areas is your company focusing on, and the top items were data analytics, the smart factory, and cybersecurity. And when we compared that data against other groups that we had polled earlier this year and several years ago, when I'd done a major study into the readiness of Irish manufacturing for Industry 4.0, we found that those topics were high on all those Paretos as well. Data analytics, the smart factory, and cyber security. We've done a poll in webinar 2, seeing what the interest was in digital twins, and 43% of participants said that their organizations are utilizing or plan to utilize digital twins in the near future. And last week, we done a survey on artificial intelligence, where 83% of participants indicated that their company uses artificial intelligence or plans to use it in the near future. So 83% planning to use or are using artificial intelligence. Over the last 3 weeks, we've done a number of whiteboard work. In webinar 1, we looked at a few questions and we recorded our information on our whiteboard, the same in webinar 2 and the same in webinar 3. So we've collected quite a picture of how we're engaging with Industry 4.0 over the last 3 weeks. So I'd like to go back to my whiteboard today, and the question I would like to ask you and to put into comments are, what will be the key technologies of the 2020s? What do you think the key technologies of the 2020s will be, based on your experience and the areas that you're currently focusing in? So if you can put those into chat, and I'll stop sharing just now. And I will switch off my background so we can see my whiteboard. Okay, let's go to the whiteboard. And Dara, if you can help me out here and capture and read out some of the answers to what will be the key technologies of the 20s be?
So one we have straight away here is the zero defect manufacturing.
Zero defect manufacturing, yeah.
I think that's something everyone can aspire to.
Yeah, so that's what takes us way beyond Six Sigma with a zero defect manufacturing. That's a fantastic vision. And many of the systems, the artificial intelligence, the better control systems are going to help us enable that reality.
Another one we have here is cobots and 3D printing.
Cobots, 3D printing, yep, we're going to see more and more of that type of automation in industry. And we had a look at last week at, the impact 3D printing is having on even creating bespoke and spare parts for industries.
Another one here we have is digital twins.
Yep, the role of digital twins is continually expanding.
That's all I have here at the moment, Billy.
They're great. So that's a great vision there for zero defect manufacturing. All this automation should make that possible. The increased use of cobots, the increased use of 3D printing, and the increased use of digital twins. So an expansion of many of the tools that are already in our Industry 4.0.
Sorry, Billy, one more thing there. So Geraldine says whole building digitalization. Would that fall under the kind of digital realm of digital twins and making a digital twin of a whole building, do you think?
It can do. The whole building digitization is, and I think what it is also is making, we talk about making the factory a smart factory. I think that digitization of a building is making the building a smart building. So you're collecting lots of information and data from sensors on your building, and you really understand how to control and manage your building. Yeah, via a digital twin, yeah.
Yeah, and Paul has said, Trusty Paul has said BIM, of course, not to be forgotten.
BIM, B-I-M, Building Information. Yep. Yep. So they're great examples of what potentially could be the key technologies of the 2020s. So let me just go back to sharing my screen again. So McKinsey recently released a study of what they believe to be the tech trends for the 2020s. These are the hot topics, the hot technology topics that they expect to be expanded on during the 2020s. The first one is, and I think we captured that already, is the next level of automation, an increase in the industrial Internet of Things. By 2025, there is expected to be up to 50 billion devices connected in the industrial Internet of Things. 50 billion, incredible. We already captured it on our whiteboard, the increased use of robots, cobots, digital twins, and 3D printing. So all these are expected to expand massively in this decade. Also, what is going to happen this decade is the increase in availability of 5G, then 6G communication. So that's going to drive connectivity, access to the internet, and allow for wireless upstreaming of data from our factories and our buildings. By the 2030, it's expected that 80% of the population of the world will be covered by 5G technology. Also, what's expected to expand this decade is cloud and edge distributed infrastructure as we move more and more of our systems from our own internal IT onto the cloud and increased use of the edge as well. So a distributed infrastructure away from a centralized one. And we spoke about this one as well, quantum computing, a new type of computing that's becoming available to us. We won't ever have them on our desktops, but we'll certainly be accessing them in the cloud. And it's going to allow us to solve problems and do much more complex computing with the power of a quantum computer. So we're going to be able to solve problems and do simulations and do advanced AI that we were never, ever able to do. And this is going to be enabled by this new type of computing and quantum computing. We'll see a huge expansion of artificial intelligence this decade with computer vision, artificial intelligence understanding video, language processing, speech technology. And you're already seeing some of that happening. Software, the way that software is created is going to change this decade. The future of program is going to change. Machine learning is going to be applied onto learning software so that systems, software that writes software, that's going to become the reality this decade, which is going to bring us what's called software 2.0, the next era of software creation. Then zero trust architecture, that's going to be about what we spoke last week about cyber security and the importance of cyber security. And we're going to see much more advanced systems based on that. And it's called zero trust architecture, never trust, always verify. And that's going to be a big theme in this decade. And one area that I would call out is biological science. There's going to be huge advances in biological, and any of you that are working out in the medical devices or pharma industry will probably be seeing this already, you know, in terms of personalized medicine, accelerated vaccine development, and the creation of food as well. Another key item for this decade will be the new materials such as nanomaterials becoming available to us and allowing us to increase the complexity of some of our manufacturing parts. Then lastly, and not least, it's clean technologies. You know, the sustainable technologies to be carbon neutral or carbon negative. We spoke in webinar 1 about the damage that the 4 industrial revolutions had done to the environment. So technologies to repair that and to stop that damage are going to be absolutely key this decade. Is there any you would add, Paul, to that list?
That's a very interesting cross-section list there. I mean, I'm looking down and they're all essential and part of the journey, but you know, the 5G connectivity we're just starting to see roll out, but the 6G connectivity will make you know, the connection of IoT that much easier. And which of those would you pick out yourself, Billy, as a lead?
There's 2 that really strike me. Well, actually 3, right? I mean, obviously the clean technologies is hugely important. The society needs to fix the damage done to the planet, and that almost needs to be the priority. But and we're going to using some of these tools, some of these other technologies are going to help us do that. I see new materials as really important because the semiconductor industry needs to continue to advance and produce the silicon, produce the integrated circuits to help us to do all this computing. And they will need to be looking at new materials that help make the advancement in quicker microprocessors and less energy consuming microprocessors. So that is key, because without those new materials that enable the semiconductor industry, none of the others are possible. Then I would be really excited about quantum computing as well. I think that the whole idea of a quantum computer is going to help us solve problems that we could never have solved in the past, do simulations that we could have never have done before. So I would be personally really excited about quantum computing.
Yeah, that's another very important one. But as you said about the the clean technologies and the nano materials, the rare earth minerals being mined from sort of Australia and places like that, to advanced technology, you sometimes wonder we're going back to years of mining to go forward. But yeah, the new materials and nano materials not needing the Earth's resources to be mined to get the electronics moving.
Yeah, so I mean that's a great point. The whole thing about, I mean, Industry 4.0 is all about improving efficiencies, using less resources, enabling technology to allow us to use less resources. So I think that will be the theme of the 2020s.
Yeah, yeah.
Now, I've called out advances in semiconductors as important because, as I said, none of this is possible without the advances in semiconductors. We already see there's a what's called a chip crunch on just now. The supply of semiconductors is limited. The semiconductor industry is trying to increase its capabilities. And it's important that we can continue to see advances in traditional semiconductors. And the two things that the semiconductor industry focuses on is making the microprocessor faster, i.e. it can switch between a 1 and 0 faster, off and on the transistor. And the faster that 1 can go to a 0 and a 0 can go to the 1, the faster the computing can happen. And the second thing is make when a transistor is in an off state, is 0, that it actually draws 0 current, so that we're not consuming energy needlessly, which is really bad certainly from battery life in a mobile computing solution. So advances in semiconductors, we will see new types of semiconductors available. We'll see a GAA that's not what you're thinking. It's a gate all around technology applied to semiconductors, and ribbon FETs, ribbon field effect transistors. So new types of transistors will become available this decade. We'll see advances in packing technology and some of those new materials that will be getting used, which will enable those faster transistors that consume less energy. So advances in semiconductors will be key this decade. Now, I've put links in there to some of the advances that are happening in semiconductors and the top trends in technology, that list that we looked through from McKinsey. They do a deep dive into those areas that will see breakthroughs in the 20s. So I'd like to talk about a roadmap for industrial advancement. So many of us today are at Industry 3.0 status. We're using computers. We've been using computers in our factories and to do our jobs for a long time. And we've seen the digital transformation started in the 1960s as integrated circuits became available and computing power became available to us. But how do we move to an Industry 4.0 setting? And we've been speaking about it over these 3 weeks. It's about, implementing decentralized decision-making policies, about introducing cyber-physical systems into our factories, about employing smart factory technology, and our use of cobots. So we can do those things. Decentralized decision-making can be helped and aided by, deploying data analytics to help people make decisions, by applying systems that we've been familiar with for many years, like statistical process control, providing training for our employees, using process improvement technologies such as Six Sigma and Lean, employee empowerment programs, training our managers in more and more sophisticated advanced leadership techniques, looking at more and more autonomy for employees. Then in the cyber physical systems world, we look at more and more sophisticated control systems in our factories, software that controls our hardware, feedback loops. In the smart factory, we need to increase the amount of factory automation using systems like OPC UA, asset administration shells, which we spoke about in webinar 2, RAMI 4.0, and having 5G networks in our factories eventually, a wireless network that collects all that data and information. And then we look at the world of cobots, systems that can assist people to achieve tasks. So employing these 4 concepts into our factories allows us to move from an industry 3.0 setting to an industry 4.0 setting, and engaging some of the tools that we've spoken about in the last few weeks, such as digital twins, augmented reality, cybersecurity, 3D printing, data analytics, and artificial intelligence, whatever makes most sense in your setting. So this is how we move from an industry 3.0 setting to industry 4.0 setting, by deploying these concepts and tools into our factories. Now, there is an indicator that can be useful for measuring your readiness for Industry 4.0. It's called the Smart Industry Readiness Indicator, SIRI. So I just wanted to bring it to your attention. And in the last few weeks, I have been giving you a call to action to review your Industry 4.0 status for key items, listing out where you already have Industry 4.0 systems or evolving systems in your factories. And then focusing on high cost areas of your factory. Where are the high cost areas where you could get a breakthrough to try a pilot? Go and talk to the technicians on your shop floor, talk to your engineers. Where is a problematic area where an Industry 4.0 solution might work? Then run it as a pilot and demonstrate to management that this can be successful. Then move out of the pilot and try to expand it into other areas. But focus on where the real need is. Where's the high cost areas in your factory? And remember, keep an eye on what your competitors are doing. I can't stress this enough. Don't work in a silo. Look, find out what your competitors are doing. What is best in class? What are they doing? Is there something you can copy? Is there something you can follow? Is there something you can learn from your competitors? Now, the Smart Industry Readiness Indicator is available and was developed by the World Economic Forum, and I've put the World Economic Forum's website connection into the Smart Industry Readiness Index there, and you can actually do a self-assessment at the website www.siri.gov.sg, and it allows you to go through a questionnaire and assess your readiness for Industry 4.0 and how to best apply it in your factory setting. And you can actually employ Siri assessors to come and look at your factory and give you professional advice on how to do that. So the next thing is about creating a roadmap. So why do we need to create a roadmap? We tend to overestimate the effect of our technology in the short run and underestimate the effects in the long run. So with technology, we always think, oh, it's going to have a really big impact to us on us really quickly. And that often isn't the case. But in the long term, technology has a big impact. If we fast forward to 2030, things will look very different than they look today. Things might not look very different by December of this year, but by December 2030, they will look very, very different. So from technology point of view, you always have to look reasonably long term, what's happening in the next 5 years. And this quote came from Roy Amara, who describes himself as a futurist. So a roadmap helps us create an ambitious long-term plan to maximise the opportunity for technology change. It's to look 5 years into the future and to establish an ambitious medium-term plan. And really importantly, it's to optimistically construct the future, to set the vision for where you expect your organisation to be 5 years from now. So construct that future, start to think, this is what it's going to look like. Now, the first thing to do when you're building a roadmap is look at your opportunities and risks. So, list out those Industry 4.0 concepts or tools. It could be the smart factory, cobot, cyber physical systems, decision-making, artificial intelligence, or some of the other tools we've spoke about that are most applicable to your setting. Then think about what opportunities this offers to us as a business and list those opportunities out. Then look at the risks. What are the risks if we ignore the trend? What's the risk if we don't engage in the smart factory or cobots or CPS? What's the risks to our organization? So have that vision set for what are the opportunities and what are the risks from Industry 4.0 concepts and tools. So build that roadmap over the next 5 years. Start to think about where will you be by 2022, where will you be by 2023, and build it all out back to 2026. Start to think, where will you be in a smart factory, cobots, CPS, decision-making, artificial intelligence, against each of those concepts and tools and any others which really matter to your setting, and start to say, where will we be over the next 5 years? So it kind of sets that vision for you and start with a roadmap to work towards. So we have a Mentimeter poll today, and we'll look at the results at the very end of the webinar. And the question I want you to answer today is, what words come to mind after this webinar series? So you've sat through the 4 webinars. What words come to mind after this series? So you can engage with the Mentimeter by using the following codes. So go to your www.menti.com link and use the code 62835506. So Dara, if you put that code into chat so people have it, 62835506. So 62835506. I'll just give you a minute or so to complete the Mentimeter survey. Then at the end of the webinar, we'll come back and look at the word cloud that you've created. So I'll just give you a minute just now to complete that survey. It's okay, hopefully you got to all to participate in the Mentimeter survey, and we'll have a look at the data at the end of the webinar today. Now, I've went a little bit quicker this week than in previous weeks because I wanted to get plenty of time for our guest speaker this week. So our guest speaker this week is Brian Cooney. He's Managing Director of KUKA Robotics. Brian has over 35 years of experience in managing robotic companies. He's now the Managing Director for KUKA Robotics Ireland, who are global industrial leaders in the field of robotics. So I'm going to hand you over to Brian, who's going to talk to us about robotics and how they can be applied in industry. So I'm going to stop my share now, and Brian, you can share whenever you're ready.
Okay, that's great, Billy. Thanks for the introduction. So I'm going to try and share here now. So yeah, so I'm going to continue talking about what robotics are used in manufacturing. Why Irish companies are investing more and more in robotics, and what the benefits are and typical use cases. And then I'm going to finish off a little bit by what's currently hot in the field of robotics. So everything that we do in our daily lives, so I mean, they've either been partially automated or fully automated, and that applies from everything from our smartphones to our game consoles, to our cars, to household appliances, from medicines to groceries, just to name a few. So robots fabricate, they assemble all manners of products, and then those very same robots pick to order, they pack, they palletize, and they deliver to the end user. So pretty much it's clear that it's already impossible to imagine what our working in our private lives would be if we didn't have automation. So consciously or subconsciously, automation is absolutely everywhere. So if we look at the sectors where robotics are deployed, they're used, I mean, again, so we concentrate on manufacturing. So robots are used across the range in consumer goods, in metal fabrication, medical device, plastics, automotive, electronics, construction. They're also used in supply chain, logistics, and transport, in healthcare, whether that be in surgical, in service robotics or laboratory robotics. They're used in the entertainment and the film industries. Yeah, and they're also used in agriculture and marine. So in other words, robotics are used in all sectors, So if I just step back and take some of the points that you made earlier, Billy, about, the use cases for automation and robotics, there has been a period of sustained growth in the deployment of robotics, over the last, 20 odd years or more, Now in 2019, that saw a significant hit. And there was a huge drop in the number of robots, being deployed worldwide, and that was attributable to COVID. Yeah, so we had a major hit, in terms of the automotive markets and the electronic markets in particular, but also in terms of the other general industry type applications that we would see robots rolled out into. But since 2020 and 2021, in the early parts of this year already, there has been a huge bounce back. Yeah, a massive bounce back in terms of we're already, surpassing the numbers that we saw, in 2018, and again in 2020. So there's huge growth across all robot sectors and automation sectors. We're seeing that all the machine builders, the system integrators, the OEMs, they're already stacked out with orders, so they're finding it difficult to even deploy more automation within their facilities because production comes first. So as you mentioned earlier, there is a chip crunch, and that's affecting now the deliveries of all components, of all smart components, whether that be sensors, vision systems, and it's also affecting robotics. So we're now starting to see where the impact on the chip crunch is starting to affect the delivery lead times of robotics, and that's right across the board. So we're starting to see this. So if anybody's in any doubt, that robotics are a part of the future, Let me dispel that doubt, because the growth trajectory is absolutely colossal in robotics and automation. So the question is why? Why? I mean, why are so many companies, deploying robotics? It's certainly not because everybody and every engineer, fancies them as their next best toy. They reduce production costs, and that's a key one for any manufacturing facility. They increase productivity, so you're getting more product out, for less effort. You're seeing a greater consistency of quality than any manual operator can consistently achieve over the length of a day or a week or a year. There's a never increasing scarcity of resources, so robotics are helping fill that gap. Also, in terms of eliminating the dirty and the dangerous tasks that nobody else wants to do, and I for sure don't want to do them either, and that keeps our health and safety people happier. They're flexible, both in terms of the manufacturing processes that they're deployed to, but also in terms of if the product line comes to an end, the robots can be reprogrammed and redeployed and reused on the new products. They can perform extremely complex operations time and time again and right every time. They help in waste reduction in terms of the raw materials that they use. They operate in reduced floor spaces, which again brings us back to the green discussion you mentioned earlier, Billy, because that means that you have reduced lighting, reduced heating, and so on. In some cases, currently, we are already at a point of lights out operations, and that's the holy grail for a lot of manufacturing facilities, to be able to close the door at 5 o'clock, go home, and know by checking in your iPad or your screen or whatever else that the plant is still running in your absence and in the absence of operators. So in the current pandemic situation, we've seen the need and the requirement for social distancing. Well, robotics are very much so helping, that case. And a lot of, especially food producers and so on, are introducing robotics because that actually helps, decrease the amount of space that's required between operations. So if we look now at the types of robots that are used within manufacturing, specifically within manufacturing, we're looking at articulated robots, so 6-axis articulated robots. These are the ones that most people would be familiar with. They can also be 4-axis robots, they can be 5-axis robots. Then you have SCARA robots, which are typically used in high-speed applications, pick-and-place assembly type applications. In the consumer goods, again, you have high-speed pick-and-place Delta robots used for sorting and packing. You have the cobots you mentioned on a number of occasions. So nowadays, there is a multitude of suppliers of cobots or collaborative robots. And what that does is it enables robotics to be used in a fenceless environment, again, reducing the floor space that's required. But more importantly, it allows humans to operate in direct collaboration and direct workspace of a robot. That obviously has its constraints in terms of velocity and mass, but that is a hugely growing trend. And as you rightly point out, it's one of the main pillars of Industry 4 going forward. Also, so is mobility. We have AGVs or mobile robotic platforms, whether that's used for transporting goods between production phases or transporting finished goods out to logistics and warehousing, or indeed where you have mobile robotics, which is the combination of the mobile platform plus an articulated robot arm. Doesn't necessarily have to be a cobot arm on the mobile platform, but in many cases, that's what it is. If it is an articulated arm that's on a mobile platform, then that still requires additional safeties in terms of floor scanners, guarding, and segregation, and so on. In plastics industries, then of course you have Cartesian robots, and you also have linear and gantry robots for large space, handling type applications. So typical applications in manufacturing, we're looking at metal fabrication. So metal fabrication takes into account everything from welding, joining, riveting, spot welding, material handling, metal forming, sheet metal bending, and so on. You have assembly, which can, again, just be about everything from assembling motors to catheters, from mobile phones to airplanes. In the consumer goods, you have what we call the 3 Ps. So that's pick, pack, and palletize. You have machine tending, which can be machine tending of molding machines, whether it's injection molding or blow molding machines, or even rotational molding. It can be CNC machines. It can be, foundry applications and so on. You have sealing and gluing and painting and dispensing robotics. You have sampling and inspection robotics and testing robotics. And these are they're just an example of the types of applications that are used within manufacturing, whether it be here in Ireland or further abroad. If we were here to try and discuss all of the types of applications that are used within robotics and cobotics, we could be here till doomsday. So if we have a little look, and we've been talking now about Industry 4, and over the last three preceding webinars, you've talked about all the enabling technologies. So what are the future of production lines? So if I take a quote from the IFR World Robotics Report in 2020, the future belongs to the digitally networked interaction of stationary and mobile robots, cobots, and AGVs, which by virtue of their unlimited flexibility grant new freedoms in production. So what does that all actually mean? So it allows us to go from what we see as being the rigid infrastructures of the production lines that most production lines take up now, whether that's in automotive, aerospace, medical device, whatever it happens to be. Most production lines have a fairly rigid, regularized structure to them. And it allows us to move more towards a flexible matrix type production environment, where the products can be taken to the robot cells. So you can have multiples of robot cells around a facility, and the product can be taken to whichever robot cell the next stage in the process is required on. And that allows us to move into very, very highly customized products. And it allows us to move towards the holy grail, of a batch size of one product, a particularly customized to you product. But the question is, how do we do all this? And again, I did mention that I'm not going to get into all the detail of the other areas that you discussed over the last number of weeks. But if we have a look and we look and say, okay, one of the key enablers is digitalization and virtual commissioning. So digital twin in the cloud. So seamless connected devices, all proven, tested, and virtually commissioned before you ever cut metal. And then they exist in parallel, to the real line in production. So that continues on through, but also more virtual commissioning. So what we've seen over the last 18 months and more, is that the traditional installation and commissioning of machines is much, much more difficult. People are not allowed to travel. You don't want to travel in the first place. So that makes it much more difficult. So many new installations of machines and systems and solutions, they're being commissioned remotely. So using digital technologies such as remote logs in, augmented reality, Google Glasses, Microsoft Teams, even GoPros. So I'm aware of some of our installations that have been done, with our integrators using GoPros and MS Teams. Yeah, and it has worked out really, really well. Also, simplified operations. So simple operation and intuitive automation solutions, which, before now, was pretty much the domain or the preserve, of the experts, the expert programmers, the expert system integrators, but that's been simplified down now. So now we have, teach by demonstration. We have object-oriented programming. We have offline programming. We have open source APIs and intuitive self-learning artificial intelligence. So what's hot in robotics? And believe it or not, there is actually a robot in there. So you have a furnace application, and underneath all the cladding and the protective sheathing and so on, there is actually an industrial robot sitting in the middle of all of that. But what's hot in robotics? So we mentioned earlier, and you mentioned earlier in the introduction, green technology and the circular economy. It's really, really hot at the moment within robotics and automation. I mean, the EU, and not just the EU, but also it'd be the Irish governments, global governments, and so on. But the EU wants to reduce its CO2 emissions, by 55% by 2030. So tomorrow's robots, and even some of today's robots, they're going to be much more environmentally, friendly and sustainable and energy efficient. In the same way for system solutions. So, for example, if we look at the robot in the picture, that's our Series 2 Quantec robot. It's one of our biggest selling units. It's used all across the board in automotive and electronics and so on. Yeah. And
So, sorry, Brian. Sorry, the slide doesn't appear to be moving on for people.
So where are you now? Are you in the green technology? No.
It's still on the first one, actually. It's not been.
Oh, really?
I think
so I've been talking through a whole slide deck that you haven't seen.
Well, I think it's been making sense, but yeah, I think you're actually sort of getting to one with should be seeing a picture. But,
this is incredible. Sorry. Okay, that's pity you didn't mention to me earlier. Because this is progressing through my slide deck on both screens quite nicely.
Brian, maybe unshare then try resharing.
Yeah. How's that?
Yeah, we can see that now. Yeah.
So you can now see my green robot.
Yes.
Okay. So apologies for that. I happen to think it was quite an interesting slide deck. I can provide it to you later anyway, and if you want to include it in any of the links, you can. Yeah. So the green Quantec robot that you're seeing here in front of you, it's our -2 version. It uses 45% less energy than the previous generations of robots. Yeah. Also, most robots on the market nowadays are almost completely recyclable. Most of the structure of the robots, are up to about 90% metal, so fully recyclable. And most of the remaining materials in the robotic systems can also be recycled to quite a high degree. And that's a focus for most robot manufacturers. So if I use this extract from a company called Indumetal, so it does go to show, the reliance and the importance of Industry 4 within the circular economy. We can see now that robotics are widely deployed, in the waste recycling industry for sorting and recycling, and that brings me back to, as I mentioned earlier, one of the drivers for robotics, and that's the elimination of dirty and dangerous tasks. I take it the slide deck is moving on now, yeah? Okay, perfect. Okay, so friction stir welding, that's one of the new hot topics. So this is a process, whereby we're joining, aluminium and copper materials, which, yes, we can join them in the past, through brazing and aluminium welding, but it's difficult, and you end up with, stress fractures, cracks, and porosity, and so on. So in this, in friction stir welding, the process, it plasticizes the aluminium and the copper, and it presses it together. So it doesn't liquefy it. So the advantage of that then is you don't have the stress cracks, and you don't have the porosities and so on. So where is this deployed? So it's used heavily in electromobility or e-mobility. So this is generally speaking around, battery packs and so on for our cars, for buses, for trucks, for trains, and so on. It's also used within aerospace. Again, like I mentioned earlier, it's a volume user of aluminium structure, architectural structures, and the automotive industry. But also, it's very hot at the moment in terms of construction and the construction industry. So, excuse me, globally, we know that there's probably going to be around about 30 billion people looking for new homes or looking to be housed within the next 20 years. But we also know that the construction sector, it's very slow to adopt this kind of technology and this industry. So there's actually very few robots currently used within the construction sector. but there is a huge volume of initiatives going on within industry and within catapult centers, universities, R&D centers, and some of the more forward-thinking companies. So areas in construction, such as the modular buildings. So we know that within modular building, you know, the savings alone on site are up to 52% by introducing modular building versus, you know, traditional construction methods. But there are also robotics being used in block laying, glazing, plastering, and so on. And within the modular building, I mean, this is one of the biggest areas where you're starting to see robotics deployed and used extensively. So also 3D printing has been mentioned quite a bit earlier. So 3D printing and composite layup, I should say. Again, very efficient in terms of materials and reduction in waste. So in the concrete printing, you're using a 1-to-1 mix, so there's zero waste. In the composite fiber layup and the 3D printing, you're able to create structures such as the expo centers here on the left-hand image, you know, which are hugely complex and very difficult to manufacture under any other type of manufacturing process. So it's really only possible by using robotic 3D printing, yeah, and robotic 3D composite layout. Again, milling and sculpting. So here we're talking about the 3D machining of concrete, resins, plastics, stonework, and so on for architectural, for formwork, for art, but also for film studio works and so on. So the image in the center there is actually by Odyssey Studios in Limerick, where they created the sculpture for what's called the Mask of Shannon, which is a commissioned art piece by Westmeath County Council. So they machined it out of resin. That then in turn is used to make the mold, which is then cast with bronze. We mentioned earlier about mobility being one of the cornerstones for the factories of the future and for Industry 4. So we're looking at autonomous mobile robotics, you know, so very large scale up to 110 ton payloads. So that's extensively used within the aircraft and train manufacturing type facilities, but also, you know, for the delivery of small parts, yeah, within production to, as I say, large scale transport. And that brings us on then to where autonomous mobile robots are also used extensively within the logistics centers. So fully automated warehouses where you have fleets and fleets of robotics, both segmented so that you know, obviously operators don't enter into those areas, but also in the use case for fully autonomous robotics. We mentioned earlier about medical robotics. So, and this is where we're starting to see a blurring of the lines between the so-called industrial robotics and service robotics. So the images that you see here in the pictures, and I'm glad that you can actually see the pictures now, but the images that you can see here, you know, so they're being used, you know, for surgical applications, for radiation therapy, for MRI scanning, and so on. But within these robots are actually pretty much industrial robots. And okay, they're overlaid with a huge amount of additional technology to allow them to be used within the surgical theater environment. But if you look at what's there, you're looking on the left-hand side there. So again, we're talking cobots. So we're talking robots that are allowed to be in close cooperation with the operators, and in this case, within the theater staff. But the other robots are also collaborative robots, just not what we expect to see. So these are the large-scale Quantec robots that I mentioned earlier that would typically be used for spot welding and for automotive assembly and so on. But in this case, they're used for scanning and for pinpoint radiation treatment. So the unit on the bottom is a unit that's called the CyberKnife. There's one of them in the Hermitage in Dublin. It's a €6 million investment. I can assure you that's not the price of the robot. And on top of that, you have by Siemens, the Siemens Artis Pheno, which is both patient positioning and MRI scanning. They're also used extensively for rehabilitation, and even on the left-hand side here, you see for hair transplantation. Yeah, but again, these are collaborative applications, just not in the industrial sphere. Okay, and that brings me to the end of the deck. So I'm quite happy to take questions, and I apologize for that you couldn't actually see the full presentation. It obviously is the trick of ending, sharing, and resharing again. But I will provide the deck, Paul, to yourself and Billy, so if you want to include it within any of your links.
Brian, well, sorry about that, but no, absolutely brilliant piece there. That was fascinating all the way through. Even when we couldn't see the slides, I think we understood what was going on. But no, that's really good. But Brian, we've both been sort of around robots for over 30 years, but I remember initially it was primarily it was perhaps the big automotive, but the multinational companies and the larger companies. But how is that geared up to now for the smaller companies?
Yeah. So when I started out in robotics first, as I say, it's more than 30 years ago. You know, and in Ireland, you know, so a relatively small market, you know, and I mean, robotics was almost unheard of. You know, you had some of the bigger multinationals, you know, so you know, the likes of the Johnson and Johnsons, you had maybe the PepsiCos, the Procters and Gambles, you know, they might have had, you know, robotics. They did have robotics, you know, but they were absolutely in the minority, you know, and at that time, you know, you're right. I mean, globally, you know, it was the automotive sector that drove it. Yeah. But since then, I mean, and for many years now, you know, the price of robotics has come down significantly. The cost of robot integration and the system build around it has come down significantly. When I started out, most machine builders, you know, would have been focused around what we would call fixed automation, so linear drive, slides, and so on, you know, and that would have been sort of their default go-to. Yeah. Now the first question they ask, you know, is how can we use robotics in these machines? You know, and that's because of their flexibility, their reprogrammability, their redeployment ability, and so on. But overall, I mean, it's really the cost coming down and the ease of use that has meant now that, you know, I mean, SMEs, this is so widely acceptable now to SMEs. You know, you're getting guys, you know, who have a small manufacturing facility. They might only have 5 or 6 people working in it, but they might also have 5 or 6 robots. You know, and that's the significant change to it. You know, and without that kind of automation, those guys couldn't survive. They wouldn't. Right. They wouldn't be in business. They wouldn't be either able to afford the skilled resources around it, you know, or they wouldn't be able to sustain a competitiveness, you know, with you know, with competitors further afield.
Yeah, that's right. And I mean, the price of in this country of labour is obviously higher than Eastern Europe and other things, but yeah, having and robots, they can work the weekends, they can do 24-hour shifts. They're quite flexible like that. But,
the other thing, of course, I mean, is that, like we mentioned before, you know, is just quality, you know, the consistency, you know. So I mean, yes, you know, humans, you know, can build, you know, to the same quality, but not consistently, not time and time again. I mean, we're all the same. We're all human. You know, you start off at 8 o'clock in the morning. Come 5 o'clock, you're tired.
Yeah.
Yeah.
But Brian, you know, everyone's talking about cobots now. Have they taken over the traditional role of robots, or I mean, this is something that we've discussed before. But
yeah, well, the straight answer is no. You know, if we look at the size of the markets, you know, I mean, cobots, you know, probably 5%, you know, of the global robot market, you know, which is quite a small percentage. But the impressive thing is that 5% didn't exist 10 years ago.
Yeah.
You know, cobots have come on such a long way in such a short period of time. I mean, it's a phenomenal growth trajectory. If you look at the, you know, the first introduction of serial production cobots to the amount of the deployment that's there now. Yeah, and the use cases, you know, I mean, every day there's a new use case, you know, for collaborative robots. And, you know, again, you know, a lot of the benefit is not so much necessarily in whether it's going to be used in a full human robot collaboration environment, but it's ease of use. You know, the simplicity of operation, you know, the acceptance by the operators, you know, the footprint that they take up. So there's huge advantages, you know, to going with cobots. But it also has to be said that, you know, it is still very niche. Many applications for robotics are either, you know, heavy duty, you know, heavy payloads, very high speeds, and so on, and they will never be suitable for cobots.
Right,
So will they take over the market of industrial robots? Never. Will they continue to grow in terms of their use cases and the percentage of that market share? Absolutely.
Yeah, I agree. There are a lot of people actually saying calling robots cobots because they are working in a collaborate, but if they're behind a fence and they're big and they're dangerous, they're still an industrial robot.
Absolutely.
That's right.
Absolutely.
AGVs and mobile robotics, you touched on a little bit there. Is that you know, the logistics operations or primarily, or
So what you would have seen in the past on mobile platform, mobile robotics, you know, and you know, there's always a debate, you know. I mean, do we call them AGVs? Are they just automated guided vehicles, or are they, you know, automated robotics, you know, or are they automated robotics with an articulated arm on them, you know? So that debate is ongoing. But the larger scale automated platforms, you know, have been around for a number of years now. They've been, like I said earlier, they've been widely used within aerospace and particularly transport type production, so trains and to a lesser extent, but a growing extent within the automotive sector. Then they became very widely deployed within the logistics, and we're all familiar with looking at the Amazon type applications and the Ocados and so on. But what you don't see is the likes of the general distribution stores, you know, the distribution warehouses and so on, where you see a lot of logistics mobile robots, you know, and that can be in the typical, you know, Swisslog type AutoStore type mezzanine mount robot, or it can be in the floor mount, you know, Fetch, Ocado type robots, but they are growing at a phenomenal rate in the amount of deployment across there. You know, but that's also then in the case for the fully autonomous ones. So most of those warehouse and distribution centers do tend to be fenced off, you know. So, you know, the product is brought out to the operator and he takes the product then off that then and does whatever he does with it, you know, sends it out to the post office or DHL or whoever he leaves it with. But you're now saying, you know, that these are actually open warehouses, you know, and the robots are autonomous, you know, so the operators are actually working in the same area as you're having the mobile robots, you know, working around in. And then of course, you know, especially for, you know, for more manufacturing type processes, you know, the use case for using mobile platforms with articulated arms, you know, it can be used for everything from assembly, you know, to transport of, you know, goods in between various production stages, to environmental sampling, to testing for non-contact measurement. The use cases are endless, you know, and it is one of the major growth factors, you know, within robotics and within Industry 4. So there's absolutely no doubt about that.
Yeah, some of the AGVs used to sort of follow a track in the floor, and now they can be programmed, or they can find sensors, or, you know, they can find a different route.
Most of them now, you know, will typically run off SLAM navigation.
Yeah.
You know, so self-localization. So they create a map of the environment.
Yeah.
And then, I mean, if somebody happens to plop down a pallet in the best route, the normal route, you know, for the mobile platform, it just recalculates the route around that.
Navigates,
you know, and it still gets to its destination, you know. So so they're so much more intelligent. I mean, if somebody dropped a pallet, you know, on an embedded circuit in the floor, well, that's it. The mobile platform doesn't go any further.
Okay. I've got one more question. I mean, you touched on it again before and mentioned the C word, but you know, how has COVID affected the robotics and the automation market? I mean, I guess a lot of people were sat there thinking, what can we do? And now we're coming out of that little, you know, is there been a big trend?
Yeah, so I mean, like I mentioned earlier, I mean, COVID in the early part of the pandemic decimated the robotics business and the automation business. I mean, people weren't buying cars, so the automotive plants weren't building cars. The electronics markets, particularly, in China, were so badly affected. I mean, production stopped. So that meant, that the electronics markets fell. And if those markets fall, and they're a huge portion for any robotics company, so that has a major effect, a major knock-on effect then to the robotics companies. But if you look at what we term general industry, which includes, general manufacturing, consumer goods, and so on, that actually remained very consistent. And in fact, actually, even towards the back end, of 2019 coming into 2020, and and certainly, in the first 2 quarters of 2021, that growth has been phenomenal. And part of that is driven by the fact that, here we have a certain amount of an element of it that the PUP payment means that people don't want to go back to work, and that, it's just a truism. It's just a fact of life, So a lot of the guys, that have been, laid off as a result of COVID, they're still getting paid plenty. They don't want to go back, especially into the lower paid categories of work. So automation is filling that gap. We mentioned, about the social distancing, it's filling that gap, because where you have long lines of production lines, where you have operators stacked, shoulder to shoulder, particularly in the food industry and meat processing and so on, you're not going to be able to have that. I mean, you're not able to have it currently, but you can't double the size of your plant either.
Right.
So the introduction of automation helps, create that social distancing as well.
Yeah, people are all scared of change, and robotics are going to take people's jobs away. But first of all, they take away the very hard and difficult jobs. But you wouldn't say, tractors are taking jobs away from farmers, are they? They're making a farm sustainable, that one person can actually make some money. And I think the same argument goes through with robots. But right, we've got just a couple of quick questions. One from the chat line. Mm-hmm. Has been a member of the NSA National Robotics Standards Committee helped you?
So our membership of the NSAI and the International Standards Forum was never designed to specifically help KUKA. So we're board member. We're on the member panel. In respect of representing Ireland. So that gives us a vote. An international vote on the standards, and every country has one vote. So if we didn't have a representative panel, with the NSAI on the standards committees, that means we don't get a vote. So that means then, as the industry standards are being handed down, and there's something there that ultimately we look at afterwards and say, well, we didn't agree with that. I mean, I'm talking about as a country. Because it has an effect on everybody. It has an effect on us, the manufacturers. It has an effect on the end users. It has an effect on the integrators. Well, if you weren't in, you can't win. So you didn't have your vote. So now we see firsthand, well in advance, what's coming down the track. You have a chance to influence it. And you have a chance to put your opinions forward. And actually, Ireland, for a small country like it, has been punching above its weight within those committees, and has had a number of recommendations actually proposed to and accepted by the international standards committees. So the purpose was never specifically to help KUKA, it's to help manufacturing in Ireland. Yeah,
it makes you wonder why certain countries would leave the EU, so they've got no influence over it. But there you go. How are we doing for time, Billy?
It would be great if you could wrap up, maybe take one more question, then I'll need maybe a few minutes just to close.
Yeah, no, there's some more question. This is from Keith. Do you see any development for standard communications for mobile robots, AMRs, AGVs, to allow AMRs from multiple manufacturers to work in the same space?
Yes, is the answer to that. So no one manufacturer, can, manufacture, all products, to suit all applications. So whether that be within, industrial robots, articulated robots, combination with cobots, mobile platforms, and so on, you're never going to be able to be that sole supplier to provide the entire gambit. So the same thing applies, within mobile robotics. You will have mobile platforms which are suitable for different applications. But from an end user's perspective, you don't want multiple platforms to have to control them on.
No.
So if you can have a common platform across which all the manufacturers can communicate, and you can have a common navigation system that can talk to all of the different platforms, then surely that brings, advantages to the end users. Getting that across the table with a lot of manufacturers is a different story.
Yeah.
So the proprietary, communication systems and platforms, but I think that's all changing anyway. I mean, that's the basic premise, of Industry 4. Any device can talk to any device.
Yep. Yeah. But I mean, as a standalone thing, that they'll have their own safety, they'll have their own navigation. They
Absolutely.
might not need to talk to each other, but you could have two different AGVs going past each other. They'll just try and not collide, but do they need to talk to each other? Perhaps they do.
They need a handshake. They need to know where they are in space with each other. You may have a distribution of tasks. So you could have a master control system, that's distributing a task to, I don't know, an Ocado, and also maybe to a Mir, maybe to an Otto, maybe to, one of the KUKA KMPs. But you could have a master control platform that's, distributing all the tasks to each of those. And again, then the other, and again, it's been mentioned on a number of occasions, is the infrastructure around that, the 5G or potentially 6G infrastructures, so you have low latency communication. Again, within mobile platforms, is that strictly necessary? Not at the moment, it's not. Wireless communication is more than sufficient. But wireless communication especially within a brownfield site, has its own challenges.
Yeah.
So certainly, the newer communication platforms that are coming out, like 5G and 6G, they're also going to have a major bearing, on the deployment of mobile platforms. Yeah,
that's brilliant, Brian. I think it's been a fascinating talk today. We could have went on for hours about this. It's a really good presentation, yeah, for everyone out there, if there is any feedback, you can fill in the feedback forms and give us a bit of guidance on where we go in the future. But thanks a lot, Brian. That really was first class.
You're welcome.
Fascinating, Brian. Yeah, fascinating. Brian, if you can just stop your share.
I'll stop sharing, yeah. I've lost my screen now.
I apologise for the.
So my stop sharing button has disappeared and my new share has come up. Okay, I think we're there now, are we?
Yep, that's us.
Okay,
yep.
you're back. Okay.
I'll go back on. Yep.
Thank you, Brian.
You're welcome. Thanks.
And we'll just go into yep. Okay, so that was a fascinating discussion, Brian. Absolutely riveting stuff on robots. I learned so much during that conversation from yourself and Paul. So if you want to learn more about, do a deeper dive than we've done in this 4 webinar series, there is additional training available on the Industry 4.0 SkillNet website. So if you visit the website, www.industry4skillnet.com, you'll see what additional training is available that go into a much more in-depth deep dive than we've done in this 4 webinar series. So up and coming classes from Dr. Salim, we have Introduction to Industry 4.0, an intensive all-day dive into the Industry 4.0 world, running on the 23rd of September and the 25th of November. So you can book those on the website. Second one is Fundamentals of the Internet of Things from Dr. Ali, who was our guest speaker in webinar 1, running on the 16th of September. Dr. Ali will go through a full day on the Internet of Things. Another SkillNet Industry 4.0 offering with Dr. Ian Keeney. He presented to us last week on artificial intelligence, and he'll be running an artificial intelligence business strategy workshop on the 8th of October. And then on 30th of September, we'll be running a class by Patrick Liddy looking at virtual and augmented reality for industry. So another Industry 4.0 SkillNet class there to do a deep dive into the world of virtual and augmented reality. So today we spoke about the Industry 4.0 factory, we spoke about future trends, we looked at how to build a roadmap for Industry 4.0, and we covered the world of robotics in some detail. We've looked at what additional training is on offer from the SkillNet website. And I have a call to action for you. My last call to action is complete your city self-assessment, your smart industry readiness assessment, complete your opportunities and risks analysis, and start to build your 5-year roadmap. What will you look like in 5 years' time? What are the steps your organization needs to take to move from implement Industry 4.0 technologies into your factories? So I'll close with a quote from Peter Diamandis, another futurist. So in the next decade, we'll experience more progress than the past 100 years. You know what? I think the guy's right. I think that by 2030, things are going to be so different from what they are today. So it's been a great journey through the 4 webinars. We've covered a whole host of topics. It's been great to talk with you and have had some fantastic guest speakers. Now, the webinar series does rerun starting on Tuesday at 1:30 Irish time. It is a repeat of this series, so if you do have any friends or colleagues that you would like to recommend this webinar series to, let them know that the series is running again starting on Tuesday.
That's right, Billy, and yeah, we'll perhaps have some different speakers as well on certain weeks, and some more updated comment. But thanks to you, Billy, as well for hosting this event, and again to Brian for his fantastic input today, and to previous speakers. It's been a good experience, and look forward to doing it again. Yep.
And there's your Mentimeter data from this week, the words that come to mind after this webinar series. There you go. That's smart factory, tool specifications, technical reports, cybersecurity, digital, they're all in there.
Yeah.
So stay connected to me. I am Billy Schofield. You can connect with me on my website at www.billyschofield.ie. You can connect with me on LinkedIn at Billy Schofield, or you can email me at billy@billyschofield.ie. So any closing remarks, Paul?
Well, just thank you, Billy. That's fantastic. And thank you for everyone for attending, and hope you got something out of it, and yeah, spread the word. And we've got a thank you from the crowds as well, the participants. But okay, well, thank you very much, everyone. Have a good day, and enjoy the rest of autumn, and look forward to your digital transformation. Okay, goodbye, everyone. Thank you.